All right, everybody, let's dive deeper into these sequences, focusing on arithmetic sequences. And actually, there's going to be two types of arithmetic sequences. One's called explicit, which we're going to focus on today, and the other one's called recursive, which we'll see later on in our unit. So focusing on arithmetic explicit sequences today, here's our learning objectives. First, I can find the first term and common difference of an arithmetic sequence. Then I can find certain term in the arithmetic sequence. And third, I can find the term in the arithmetic sequence given its value. Some vocab to go over. A lot of this we've seen already, but just to review real quick, sequence is a list of numbers that follow a specific pattern. If we're talking arithmetic sequence, that pattern is a constant increase or decrease. Basically, we are changing by either adding or subtracting the same number every time. That constant, which we use the variable d to represent, is called our common difference. And to find that common difference, we subtract any term from the one that came before it. So if we have this sequence here, this list of numbers, 2, 5, 8, 11, 14, we can determine if it's arithmetic by looking at the difference between each number. Simply take the numbers and subtract them, and we can find out what that common difference is. So 5 minus 2 makes 3, 8 minus 5 makes 3, 11 minus 8 makes 3, 14 minus 11 makes 3. It's the same difference every single time. We know this is an arithmetic sequence. Getting into some examples. Find the first term and common difference of each arithmetic sequence. So here's our first one. We have 4, then 9, 14, then 19, then 24. Determine if it's arithmetic. Say what the first term is, what the common difference is. Well, first term is as simple as it sounds. It's just what the first number is in our list of numbers. So our first term is 4. Then find the common difference. What are we adding every time to get to the next number? I know it's adding because my numbers are getting bigger in the list, so I'm adding 5 every single time. Here's my second sequence for this slide. I have 34, 27, 20, 13, 6, negative 1, negative 8. My numbers are getting smaller, so if anything, my common difference is going to be negative because we're subtracting every time. My first term, first number in the list, that's a little simpler to see. That's just 34. Now we can find that common difference by subtracting or just looking at our numbers here. I have 34 minus 27, which makes 7. 27 minus 20 makes 7. 20 minus 13, 7. So our common difference is subtract 7, negative 7. Make sure that common difference is the same every time. I believe in the last video, we saw an example where the first few followed the same pattern, and then after that, it went totally random. That's not an arithmetic sequence. It has to have the same common difference throughout the list of numbers. So make sure they follow that pattern all the way through. Next, the first term of an arithmetic sequence is denoted as A with a little 1 on the bottom. That's just first term. We can add D, that common difference, to get the next term. There's a pattern. Therefore, there's a formula we could use to find any term in the whole sequence without listing the whole thing out. This is a shortcut. This is the thing that I, as a lazy mathematician, love to find. So let's get into this shortcut. Look at this sequence here. We have 3, then 7, 11, then 15. We know the first term right away. It's 3. And then hopefully you can tell what the common difference is by looking at what changes every single time. I'm adding 4 every time. So my common difference is 4. Using those and coming up with a pattern, I notice it's 3, then 3 plus 4, then 3 plus 4 plus 4, then 3 plus 4 plus 4 plus 4. It changes by adding an extra 4 every single time. Because of that, notice it's 0 times 4, a 1 times 4, a 2 times 4, a 3 times 4. That's 1 less 4 than the position we're at. That's a huge hint when it comes to where this formula came from. To find any term in an arithmetic sequence, you could use this explicit formula. An equals a1 plus n minus 1 times d, which sounds a little complicated, but all it really means is the nth term of a sequence, whether it's the last number of the sequence we're looking for or any number of the sequences we're looking for, is equal to the first term plus our position of the term minus 1 times d, our common difference. I have a feeling this still might be a little complicated, a little confusing. So let's go through a couple examples of this, and hopefully it'll make a lot more sense. But explicit formula for arithmetic sequences is this formula right here. So looking at this example, we want to find the 14th term of this sequence. We have the first 4 numbers. Now we can just continue that pattern all the way up to 14, but that would take a little more work. Let's use what we have, plug it into the formula, and then solve to get the 14th term. We know what the first term is. The first term is the first number in the list. It's 4. Now, can you tell me what the common difference is by looking at the pattern with this sequence? Hopefully you notice we're adding 3 every time. So our common difference is 3. My first term, again, was 4. I'm looking for the 14th term, so that gets plugged in for n. And my common difference you saw from before was add 3. So I plug those values in, and now I just simplify. Dealing with the parentheses first. 14 minus 1 gets me 13. 13 times 3 makes 39. 39 plus 4 makes 43. Now you could test me on that one. If you want to count 4, 7, 10, 13, and go all the way up to the 14th term, you'll see that it's 43. But instead of doing all that work and counting all the way up to the 14th number in our sequence, we could just plug it in, simplify, and find the answer. As a lazy mathematician, this is the way to go. Let's try another one. Looking at this example, it says find the 14th term, so 14th again, of the sequence with the first term of 5 and the common difference of -6. So this one will be a little easier than the last one. We don't have to look at the list of numbers to determine what the first term and what the pattern is. It's given to us right here in the problem. So let's plug it in. We're looking for the 14th term. So we know it's going to be a with a little 14. Our first term was given to us. They said it was 5. N is 14 since we're looking for the 14th term. And then our common difference was given to us. That's a -6. Solve it the same way we just did in that last example. 14 minus 1 makes 13. 13 times -6. Ooh, that's a tough one. -78. 5 plus -78. -73. So the 14th term in this sequence is -73. What it's telling you is that if you wrote this pattern out, if you had this list of numbers all the way out till you had 14 numbers in that list, that last number would be number -73. But instead of writing out that list to get 14 numbers, plug it into the formula, simplify, get your answer. Let's do some more. Sorry, excuse me. Now, in this time it says in the arithmetic sequence 4, 7, 10, 13, which term has a value of 301? Now, we could continue this pattern and work our way all the way up to 301, but that'd be a lot of work. And this is when it becomes more valuable to use the formula than to actually write out the list. Be careful with this one, though, because they're not telling us, they're not asking us for the 301st term. They're asking which term has a value of 301. So if we go back to our formula, instead of plugging in n, we're actually going to solve for n by plugging in our value 301 in on the left side and plugging in our first and our common difference and solving for n. So here's what I mean. We're looking for the value that has, we're looking for the term that has the value of 301. So 301 is the left side. My first term is still 4. My common difference is still 3. But the n, the position of this number in our list of numbers, is unknown. So let's simplify this and solve for n. Starting with the parentheses again. This time we have to distribute. 3 times n, 3 times negative 1 becomes 3n minus 3. Now let's combine some like terms. On that side, I have two constants, positive 4 and negative 3. Combine those together makes positive 1. 2 more steps to get that n all alone. Let's get rid of that plus 1 by subtracting. Subtract it on both sides. 301 minus 1 makes 300. Last step, we got to get rid of that times 3. Get rid of times by doing the opposite, by dividing. Divide both sides by 3. I get n is equal to 100. So it turns out that in this list, in this sequence, if I write out 100 numbers following the same pattern, I would get 301. But instead of doing all that work and writing out 100 numbers, I could just plug it into the formula, solve, and then find the value. Moving on to the next one. Oh man, this one's a little tricky here. Try to stay with me on this one. Most of the questions that we go over will not be dealing with stuff like this, but I want to give a challenge to some people because I know a lot of people like challenges. So take a look at this one here. It says, in an arithmetic sequence, the term 10, the 10th term is 33, and the 22nd term is negative 3. What's the first 4 terms? So this one's tricky because they don't tell you what A1 is, they don't tell you the first term, and they don't tell you what the common difference is. We have to use our knowledge to try to figure this one out. To do so, we're going to set up a system of equations. Knowing that our 10th term is 33, we could plug in and have the 2 equations left over. My 10th term means that my n is 10, so 10 minus 1 makes 9, and I know it equals 33. Same thing for the 22nd term. So I plug 22 in for n, minus 1 makes 21, and all of that together equals negative 3. So now I have these 2 equations. 33 equals a1 plus 9d. Negative 3 equals a1 plus 21d. Solving using our system of equations methods. I can eliminate these by getting rid of the a1s together. If I do so, I end up with negative 36 equals 12d. Divide both sides by that 12. I get d is equal to negative 3. So my common difference, my pattern in this sequence is subtracting 3 every time. Now, let's use it, plug it in, and find out what our first term is. I'm going to use the 33 one because that has more positive numbers. So I have 9 times my common difference, which we found was negative 3. 9 times negative 3 makes negative 27. Get rid of that negative 27 by doing the opposite, adding it. 33 plus 27 makes 60. So my first term is 60, and my pattern, my common difference, is negative 3. So I'm going to start with 60 and subtract 3 every time And I can find my first four terms: 60, 57, 54, 51. And if I continued this sequence to the 10th term, I'll have 33, which was given to us in the problem. And if I continue that even more, the 22nd term will be -3. This is like as complicated as it gets here for explicit arithmetic sequences, guys. The majority of the questions I'm going to ask you is, can you find the first term, find the common difference? Can you use those, plug it into the formula, and find any term or the value for any term? And then I might also ask you to find the position in the sequence given a certain value. But if you know how to do this, then you really understand your arithmetic sequence. Big picture, guys, you have a list of numbers. It follows a pattern. That pattern is our common difference. The first term in that sequence, the very first number in our sequence, is the first term. We could use that to solve for a lot of things. All right, almost done with the video. I want you to try finding the first term and the common difference of each of these. You have this first one, 1, -4, -9, -14. You have this second one, 11, 23, 35, 47. For the first one, first term right away, you should be able to see it's just 1. And then if you subtract them, you'll see that that common difference is -5. And we are subtracting 5 every time. So there's our answers for the first one. Answers for the second one, first term is 11. Subtracting them, you'll see you get 12. And we are adding 12 every time. So our common difference is +12. That's all I got for us in this video, guys. Email me if you have any questions. We'll do more with practice problems and hopefully have this make more sense. Thanks so much. Talk to you guys later.